Hello everyone, and welcome to the NuScale Robotics presentation on how adding inspection to machine tending improves output and quality. My name is Stefan Friedrich from NuScale Robotics on the sales and marketing team, and I'm based out of our facility in Victor, New York. I've spent the past 5 years working for NuScale Technologies to deliver high precision motion systems to industrial and OEM manufacturers throughout the world. I've supported the sales and marketing at NuScale Robotics since we launched in 2018, working closely with manufacturers and distributors to identify part handling and inspection automation applications, bringing together the partners and technologies that are required to solve our customers' automation projects. So today we'll review some typical machine tending applications with collaborative robots and how the use of cobots and quality inspection can be applied to both traditional machine tending for fabrication, as well as some non-traditional machine tending applications to automate the use of your company's existing QC technology within the metrology lab and production floor. We'll talk about the benefits of adding quality control directly to the production floor, as well as the benefits of automating offline inspection within a quality lab. I have several application examples and several videos that we'll review throughout that I think you'll find useful. So NuScale Robotics is a division of NuScale Technologies, and we have over 18 years of experience and numerous patents in micromotor and motion systems development. NuScale Robotics leverages our existing motion control expertise to design and manufacture reliable, high-precision end-of-arm tooling and application kits for enabling automated dimensional inspection with collaborative robots. We're experts at merging metrology with cobots, and we're the only UR Plus partner that has a UR Plus certified application kit for quality inspection. If you'd like to learn more about our company, please visit our virtual booth at the Cobot Expo. And if you have any questions, please feel free to add them to the chat, and we will address them throughout the presentation or at the end. We can also have an offline conversation if you want to discuss a specific topic or application in more detail, and I'll have my contact information listed at the end of the presentation. So I thought it'd be useful to frame our presentation today around what's currently happening in manufacturing and highlight some industry trends that are important to this conversation around machine tending and quality inspection. So most of these challenges and trends in the industry are really interrelated, and they're all quite important to think about. So the first trend here is the labor crisis and the lack of available labor in manufacturing. And I'm sure that a lot of you are familiar with or have experienced the impact from the labor crisis and the resulting challenges that can occur, especially associated with attracting and retaining staff, which for many manufacturers has become greatly compounded by the COVID pandemic. A lot of manufacturers we speak with, they really cite this as the #1 business priority as they move forward over the next several years. And there's a lot of data on these trends, and with an aging workforce, manufacturers are really losing a large knowledge base as skilled employees with 40+ years of experience retire faster than the new employees that are entering the workforce. And we found that many manufacturers tend to lump QC into overhead costs, and that it's really not often considered a starting point for automation, even though QC is full of expensive, labor-intensive, manual, boring, and repetitive tasks that are really great candidates for automation. Labor is often the biggest overhead cost for a quality department, and why is that? It's because quality is a critical function within an organization, and you need skilled and highly trained operators to help you do the job well. And most QC processes are also manual, so this really leads to high overhead costs. So in quality departments, CMM and other skilled QC programmers are in short supply for employment in metrology labs, so many manufacturers hope to automate functions of their job to maximize their time programming and optimizing any inspection processes that they're trying to implement. And on the production floor, manual inspectors are often hard to come by, and they're also hard to retain because they're often doing dull and repetitive jobs like measuring baskets or boxes of parts all day. I speak with many manufacturers that solely justify their investment in automation because they need to reduce turnover within their quality labs and QC departments, for tasks that are normally what they consider their worst QC tasks. The second industry trend I'm seeing is the desire to collect more data. There's a huge demand in manufacturing to collect data in really every aspect of a production process, especially quality control. And that's because more data lets you make better decisions and improve your processes. However, in spite of that trend, a recent article that I read in Quality Magazine cited that Infinity QS spoke with 260 manufacturers about their data collection, and they found that 75% of those surveyed are still collecting data manually, and that 47% still rely on pencil and paper. And I thought that was fairly unbelievable considering the levels of buzz around Industry 4.0 these days and the digitalization of data. And data integrity is also becoming even more important, especially in regulated industries. So using robotics to help you automatically record and store this data should really help you improve the accuracy of data collection and reduce the likelihood of falsified data to help you avoid non-conforming inspection ratings. We're seeing many manufacturers recognize the benefits of digitalizing their data and are searching for solutions to interface all of their measurement data for analysis within a single software program whenever possible. So the third trend that I see frequently is the desire for easy-to-use automation as well as quality control technologies. So while automation is seen as a way to fulfill the skilled labor gap, it's also seen as a way to attract and retain workers. And employees want to feel that their employer is really on the cutting edge of technology and using that technology to their advantage. It also shows, not only their employees, but their customers that their company is working to improve its business with new technology and has really strategically positioned itself within the market with those technologies to succeed. There's also a strong desire towards the integration of safe for human technologies like Cobots, automated mobile robots, smart conveyors in factories. And those can also help with a socially distanced workflow while also having built-in functionality to keep workers safe. We're also seeing a lot of bottlenecks identified within quality departments, especially within metrology labs. And most companies, particularly those with limited automation expertise, really want to see what we call the application of automation as well as inspection systems, meaning that these technologies have to be easier to use, learn, teach, and adapt, just like the apps on our smartphones. Universal Robots and strategic partners like my company, NewScale Robotics, have really worked to be on the cutting edge of easy-to-use automation to ultimately empower companies to automate quickly and strategically. And there are a lot of technologies to aid in autonomous machine tending. So I'm going to focus on an often overlooked aspect of that production process, quality control. So most of the time when we think about any robot for a machine tending application, most people envision a robot sitting next to a CNC machine, pulling parts from a chuck, placing them into a bin, or pulling parts in and out of a press brake, or perhaps next to a molding machine and binning parts. Applications like these are really commonly advertised and are probably on display at many of the other virtual booths today during the Cobot Expo. And these are great use cases for cobots. They're automating dull, dirty, and dangerous jobs, and they're usually quite easy to program, involving basic pick and place functionality and communications with the machines that are actually fabricating the parts. This also frees up a machine operator from that machine and allows them to go do more productive tasks within the facility or focus on other fabrication equipment or processes that might be more complex and really better suited for a person than a robot. But pulling parts in and out of a machine is just one piece of the puzzle that's required to fabricate a part. And there's a lot of other post-fabrication processes that a machine operator or other production staff are responsible for. And this might include, any of the following on my list here, like cleaning, deburring, palletizing, sorting, or even inspection of these parts. Some machine tending operations that I've seen have started to include these functionalities as add-ons to their machine tending cells, but there's really limited options for QC inspection, and it's often an overlooked aspect of the machine tending robotic work cell. And operators would be expected to periodically check these dimensions to verify that parts are being produced within tolerance, so why shouldn't your cobot have this requirement as well? So inspection is one of the most critical tasks to automate if your goal is to have a fully automated cell, especially one that can run lights out and continuously produce parts without an operator having to tend to the QC functions of the machine. So every production process needs a quality department, even if that's the bane of your production manager's existence. So if you can't measure your process, you can't improve it, which is really why the QC department's so necessary. So traditionally, when you're inspecting and collecting dimensional data on parts, you have really two primary methods that you see in most production facilities. I like to classify these as in process on the production floor and offline in the QC lab. So, method one, the parts are measured on the floor by an operator or an inspector with manual tools. And this data can be recorded manually, like what I'm showing on screen, or it might be recorded with a direct connection to your SPC software. And this is a really good way to quickly check critical dimensions to verify that the process is producing in-spec parts. But having to use tools for hours on end is prone to error and over time, maybe even repetitive stress injuries. Every operator measures the part somewhat differently with manual tools, and that's why you use multiple operators during a gauge R&R study. They might apply different levels of force with their hand while using a manual tool. They may grip the part in a different location or angle than another operator, or they might record the data incorrectly due to a rounding error. Maybe they wrote the number down wrong because their handwriting's bad, or they were distracted or just tired. And throughout a production day, operators are often asked to sample parts throughout a process, and this is something that can often be overlooked or forgotten or skipped entirely as operators are required to adapt to the new challenges or tasks on the production floor. And these inaccurate measurements from any manual tool or forgetful operator who might accidentally allow the machine to run for prolonged periods of time without making these process adjustments. This can lead to failing batches of junk parts that need to be reworked or scrapped entirely, both of which are unnecessary expenses. Or you end up with a bunch of good parts that have been rejected, or some bad parts that ship to the customer, or insufficient data is captured to enable any sort of continuous process improvement. Inspected features are also often limited by the basic tools allocated to the production floor, and some advanced shop floor inspection equipment is starting to become more popular and readily available, but many manufacturers that I speak with still rely heavily on their metrology labs for more complicated geometric tolerances. So method two is bringing parts into the metrology lab where they're carefully measured on more advanced inspection equipment like the CMM pictured on the right here on this slide. Or maybe you might use a vision system or something like an optical comparator. This is a really good way to measure geometrical tolerances using more advanced equipment that really far exceed the basic dimensional tolerance data that you can get on the production floor. And this type of inspection work often involves loading parts in and out of pre-programmed inspection cycles on these machines, which is often a really boring, time-consuming, and expensive operation, falling nicely into that dull category, making it a really ideal candidate for automation. These routine inspections are often performed by highly trained and well-paid inspection technicians that have spent considerable training time on these more advanced inspection tools and whose time is really not best spent loading parts in and out of a machine all day, especially in an environment where manufacturers are facing a labor crisis, with a lot of open positions for skilled manufacturing staff, including QC inspectors. So companies like NuScale Robotics are developing technologies that can be used to automate inline inspection, like our gripper caliper, to enable QC automation at roughly the same speed as a human operator, take up the same amount of space that a person would need to manually inspect parts at a bench, and eliminate data collection errors. And this also helps free skilled operators to do more productive QC tasks, as I've mentioned, like more intricate or complicated inspections, or perhaps spending more time to program their CMM or other inspection equipment in the metrology lab. And periodically inspecting the dimensions on parts to verify that they're being produced within tolerance helps machinists determine, whether or not the process is performing correctly. And this dimensional inspection data can really reliably provide insights into process changes. So for example, this can indicate whether or not the tooling on a machine is started to wear out, based on the measured dimension that you collect. And this will require that the operator stop the process temporarily to adjust an offset, or perhaps even swap out a machine tool. I speak with manufacturers that have implemented robots for machine tending, but find that they keep producing runs of junk parts because they really haven't solved the QC piece of this fabrication equation. And adding QC automation to a standard machine tending operation can really help you better understand and prolong the life of your machine tools, while also allowing for preventative maintenance. So, robotic calipers tend to exceed the repeatability of human operators, allowing you to collect better data and make more informed process adjustments. So once you understand the correlation between a part tolerance drift and the wear on a machine tool, it may even be possible to automate the offset adjustments on your machines, enabling completely lights out automation. So this is a demo that we created some time ago with the UR distribution partner ADI, where a precision gripper caliper on a UR5E is picking and placing parts out of this Herco machine. And then they place the parts onto this output fixture, and the critical dimension, the outside diameter, is inspected to determine if the part is within tolerance. So you can see in the video we had swapped in a 3D printed version of the same size part, which was out of the tolerance window. And so the robot made an in-process decision to move that part to a fail location. This is a really good example of one way to use Cobots for QC automation in a machine tending environment. And in a production setting, the Cobot can be configured to notify an operator when a part fails and require them to inspect or perhaps service the machine before restarting it. Or as I mentioned, if you get more advanced, it may even be possible to set offsets automatically within the machine based on the measured dimension. In an injection molding setting, this same type of process can occur on molded parts to inspect any sort of critical dimensions, and that will really help us ensure that our molds are producing good parts. And if they start drifting out of tolerance, that's another indication that maybe molds need to be replaced, or we need to come over and service the machine. So in this application, our customer OptiPro Systems used a UR3E Cobot with precision gripper caliper to inspect the dimensions on a large stack of cored lens blanks. So this production process involves large stacks of laminated glass that are bored out, which produce several batches of lens cores like what you see on screen at one time. And this really requires that an input tray is loaded into the Cobot inspection workstation, which is different than the single part feed we saw in the previous application. And using a tray really allows you to load your tray, hit play, and walk away is what I like to say. And it really lets you just autonomously play through the inspection cycle and free your operator to do other tasks throughout and focus on things that are a bit more productive. So the Cobot can pick parts from the input location, measure them and inspect them, and place them into fail bins or trays and It'll also generate automatic inspection reports that can be used to improve your process on the next run and ultimately help you improve yields and reduce scrap. While also eliminating the requirement for your operator to stand there and waste time inspecting parts. So during the optical fabrication process, regular quality control checks are required to ensure that the parts are being cut and ground within tolerance. And this can occur at early stages of the fabrication process, such as the production of lens cores, like what we're showing here, or later in the production process as those blanks are cut and ground and polished into precision optics. And this can also be true for many precision metal part fabricators as well. And I speak with a lot of metalworking manufacturers that only spend a fraction of their labor time on machine tending and really actually do most of their work in the post-machining processes, which also require regular QC checks throughout, depending on what that process involves. So, the nice thing with collaborative robots is that the flexibility of them allows you to load many different part types onto one workstation and inspect really high mixes of parts and redeploy them for new applications. Because once an initial inspection program is set up with a cobot, redeployment for those other tasks will only take minutes. And this can really empower your staff to automate any routine inspection process on your floor that you wish to have an automated process for, and also handle many different batches of parts within a production shift. So now that we've talked about some inline inspection on or near the production floor and the machines that are producing the parts, I wanted to talk about some offline inspection solutions like those that are completed in a metrology lab. And many manufacturers that we speak with are dedicating more inspection work to their quality labs to meet the industry's really growing demand for stricter QC requirements and more data. And sending more and more parts to the QC lab can often lead to bottlenecks within those metrology labs that are really often unnecessary and expensive. And I think there's a really big opportunity cost to dedicating your valuable inspection equipment to high volume, routine dimensional inspections, which can end up backing up your entire production line. So this application here is an example of what I would classify as a non-traditional collaborative robot application. No parts are really being fabricated by the machine here, that we're working with, but you still gain value from freeing your CMM programmer from having to babysit this machine all day and load parts in and out all day long. It's a really expensive operation for a skilled CMM technician to be performing, who are often paid anywhere from $25 to $30 per hour or more. And the cost of implementing this type of machine tending solution for your CMM is really comparable to the total annual cost of 1 to 2 full-time CMM programmers. So it's pretty affordable. There's an application preview that I've been playing on screen here. If anyone is interested in learning more, it is available on our website as a full customer case study. And in this application, we redeployed our Q-span gripper caliper from the previous application you saw in the lens cores to measure and perform a pre-check on the width and OD of some precision optics before they're actually loaded into the CMM. So the measured dimension on the part will trigger a specific CMM inspection program for that part based on the identified measurement before it's loaded. So for example, if we picked up a part and identified the dimension as 10 millimeters, we would know that we have part A, triggering program A to initiate on the CMM after the part's loaded. And if we picked up a lens that had a dimension of 10.5 millimeters, for example, we would know that we have part B, and we would trigger program B to start on the CMM after the part is loaded into the measurement fixture. There's also other added benefits of using inspection application kits for this type of process. So, if we can pre-inspect the parts, we're already measuring the width or outside diameter in this case. We can also add in additional cost savings and maximize the uptime of your CMM if it's acceptable to pre-fail bad parts and add in decision making to exclude those bad parts from your CMM inspection program. So, for example, if an inspection application takes about 5 minutes to inspect one part with the CMM, we could actually pre-inspect some of the critical dimensional tolerances on the next part that's on deck while that CMM is running on another part. So if we determine that a critical dimension is failing with the robot before loading, maybe it's the diameter or the part thickness, we can actually pre-fail that part and never place it into the CMM, saving us that 5 minutes that it takes for a CMM cycle and allowing us to focus on other parts that need to be inspected. So here's another non-traditional collaborative robot machine tending application. This video shows how a Cobot can automate air gauge measurements. And air gauges are extremely accurate and reliable technology for making fast part measurements with micro-inch precision. And many of you that support industries like aerospace, automotive, maybe even medical customers, you're all very familiar with this type of technology and its capabilities, and it's really a requirement if you're doing fast, fast inspections on the production floor. So they generally require part loading with a very tight clearance, and this video demonstrates how an older type of technology like air gauges can really benefit from the automation capabilities of collaborative robots. And this application demonstrates how our Q-span gripper caliper can actually work in tandem with other machines to automate part picking and placement with inspection to meet your extreme high precision inspection requirements. New technologies also offer the ability to communicate with air gauges to extract the measurement values and catalog them for analysis by your QC team. Really, enabling that additional collection of data to give you better traceability, and overall accuracy of the data that you're collecting. So, in summary, how can adding QC automation to machine tending benefit your business? So, one thing we've talked a lot about is reducing unnecessary labor on routine inspections to lower your manufactured cost per item and to lower your total costs. We can also create a more flexible and scalable operation to help you improve profitability and prepare for future production changes as demand changes. It can help you improve process control to improve yields, reduce scrap, and also increase traceability to better meet compliance. It can also help with employee engagement to move them to more productive and complicated tasks that better use their skill set and capabilities, while also enabling lights out production. And we can also improve gauge repeatability and reproducibility of your inspection processes by removing operator variability from those inspection processes. So I'll now be answering some questions in the chat box on the right of the screen. And if you have any additional questions that you wish to discuss outside of the Q&A, please feel free to visit our virtual booth. My contact information is also displayed on screen, so please feel free to contact me directly. I want to thank you all for attending my keynote presentation, and a special thank you to Universal Robots for hosting this event and inviting NewScale to present and share our knowledge about automating quality inspection with collaborative robots. Hope you found the presentation to be of value, and thank you all. Take care.